Test.
Hello. Can you hear me also?
Can.
What about me? Hello, is my mic working?
Can.
Yeah,
Can hear.
can
Yeah.
hit. Yeah, can see this code screen, right? Okay, so maybe I start first. So I'll be sharing about Ray. So Ray serve is like to it's like a way to serve your ML models. So I just do a quick demo first. So like I have a Docker Compose file, right? So to start Ray, you need a Ray head. So this Ray head, inside Ray head you need to install Podman because Ray uses Podman to spin up like more instances of your models. So when you want to serve your models, so for example, I want to serve this detector, so I can put it into a class, or it can be like a Python function. So for example, here I want to serve my YOLO V7 model. So when I initialize, I import my module, my YOLO V7 package. Yeah, then when I want to run it, so in my main code, I will do like a get detection stick frame. So here I pass in like one frame, right? So you go into this function, which will only run on one frame at one time. But then if you want to do batching, like for more efficient inference, right, like faster, more throughput, you can do a serve.batch. So this function you need to write it yourself to like get your models to run on a lot of frames at the same time. So that's the idea. Okay. So here you can also when you deploy your function, you can specify like how many instances you want to spin up. So there's like the auto scaling function. I can say like minimum I want to deploy one instance of this, then maximum I can go up to two, or I can do like three, four, five, depending on like your GPU. Yeah, so here I specify maximum two. So the idea is that when there's too many requests at the same time, right, then there's a lot of pending tasks, Ray will automatically spin up one more instance of this detector for you. So you can have like two of it running at the same time. You can also specify like how many CPU and how many GPU is needed. So this one it doesn't limit the amount of resource that this instance can use, but it's used by Ray to say, okay, let's say you only got one GPU, but you specify like this function requires 0.25 GPU. So the maximum Ray will spin up is 4 instances. So that's the thing that Ray used to like, help you to scale. But it doesn't limit up, so it can still go out of memory. Yeah. So this one I need to time it. Okay.
Sorry, Ying Hui.
Ah,
Before all that, can you like go through the underlying architecture of how this entire array, the architecture itself, like what makes this possible?
okay. Wait, I got a link somewhere. Wait. There's a white paper. Yeah, there's a Ray architecture white paper. Wait, I send this link. Okay, so they got say that yeah, so you have like let's say you have a cluster, right? So one node is one machine. So you have a head node. So in my case, it's only one laptop, so it's just one machine. So in each machine, there will be an object store, which is like a shared memory thing that Ray can use to like pass very big objects to different workers. So you can have multiple different workers. Like in this case, my one detector is one worker. Then there's also a control store that say managers help you to schedule your jobs across all these workers lah. Okay, and then underlying it, there is they use gRPC for like small objects. I think it's built on Apache Arrow. So they got say somewhere, I forgot where I saw it. So small objects will be used. It will use a shared memory within the worker itself. But let's say if you have very big objects, right, you can put it into the object store. This is like the shared memory across within the machine. And then if you have multiple machines, so like one cluster, it will be a distributed object store, which is similar to Apache Arrow. Yeah, so that's the underlying how they like do all the object transfer between the different workers. Yeah, you can go read this thing.
Okay, but previously you show you're using Kafka, right? So you are not using the Kafka as the transfer mechanism now lah.
Yeah, no. So now within my Ray pipeline, I totally rely on Ray. I just use Kafka to inject the very first frame.
So that means your first component is a consumer out of it. Then after that, everything is handled by the Ray already lah.
Yeah, so like in my main code, right, I got a Kafka consumer, which is not, so far I haven't put it into Ray yet. So it's a normal Kafka consumer. Yeah, so I read the latest message. Then after that, I put it into Ray.
So this is like your main function lah.
Yeah,
the entry point, is it?
The entry point, yeah, correct. So the Kafka is like totally separate.
What's the code? What's the link to the head inside here?
The link to the Ray head, is it?
Yeah, from your main, then how you link to the head?
Okay, so the Ray head is like it's like to spin up a Ray instance.
Correct. Then how do you contact this? How do you contact this head?
Then I got another Docker file. Okay, this one actually you don't need to be a Docker file. It can be like, for example, ClearML on AIP, right? You have a virtual environment, also can. But here I choose to put it inside a Docker file lah. So this is just a very simple file. So basically, it's just a very small file lah. I just need to pip install like Rayserve. Requirements is just Rayserve. Then because I need Kafka, so I install Kafka. So that's all inside my this image. So I will run my code within this image, but then when I run this code, it will send like so this code inside my code, I will run this also. So this one it calls the Ray head. So like you say, you try to find like a head, right? Let's say it's a cluster or function, so it will try to find the head node. Then it will run a deployment of my detector, which will spin up inside the head. Yeah, so I can show it to you.
Okay.
So like I start my stuff. It's also integrated with like Prometheus and Grafana for like metrics. So you'll be able to see like you'll be able to see like some dashboards, like some later it will start showing after it starts running. And then it's also integrated directly with the Ray dashboard. Yeah, then you can see it start showing already. So now I have like, okay, so in this code, right, I try to show you all that I start two different workers. So you can, this one can be like a different thing, no need to be a detector. It can be like a tracker or like a VID. So it's two different functions. So one, I start it as a detector. Then in the other code, I call it a different name. So this initialization is still the same because it's calling the same Ray head. It's the same cluster. But then I name it differently. So if I go into my head, right, then because Ray uses Podman, then I can see that it starts two containers inside. But if I do it outside, you can see that there's no extra containers that you can see. So if you are just looking from it outside, there's only like a Ray head and a Ray driver. But if you go inside the head and you try to see the containers inside, it spins up inside. So it's like a Docker in a Docker kind of thing. Yeah, so within your ray head, so because it's like Docker in a Docker, right? In your ray head, you need to install Hotman and NVIDIA Docker. Yeah, so that's the two most important things, ray head and NVIDIA Docker. Okay, so now it's running. Then I can show you the auto scaling. Yeah, so now it's one detector and one detector 2. So in my code, in the detector, I say maximum I can scale to 2, right? So we start. Like, send some frames. Okay. Yeah, then we should see some results coming. So it's running. Then after a while, it should start to spin up more instances. It should auto scale up. Okay, so if you go into actors first, so it's scaled already. You can see like there's 2 detector now. So if you go into all these instances, right, within the array dashboard, you can see like how many pending tasks, how many executed. So there's a lot of metrics that you can use to see like the current status of your array cluster.
Where's the part where you build the pipeline?
Okay, yeah. So here you see it scale up. Okay, the pipeline, which one? The main pipeline is it? So here I have 2 detector. So in my pipeline, I get the status frame from the Kafka. So here I just doing a very simple, put the frame inside the 2 detector just to show the scaling. So each frame is passing through 2 detectors, but it can be like a detector and a VID.
So that means it's branch. That means this loop is like what? Is it like a while loop?
It's
Then
the while loop, yeah. Because I continuously get the latest frame.
so that means the way they choose which detector to which component to go to, right? It's based on the dummy task type, is it?
It's based on how I want to write it. Also in this case, I say, in this case I'm saying I want to put the same frame into 2 different jobs, like 2 different instances. I want to put it into ray detector and ray detector 2. So
Yeah.
both are running, yeah.
Yeah. So after you put already, right? Then you have then how do you how does it know where this task is the IEID, is it?
So what do you mean?
Is the so what's after, is there a component after this detection?
So for now, no lah. I just get it working only. So I haven't chained it up yet.
But how is the training like, or you haven't like reached there yet?
Okay, I can show. Wait, so let's say I want to scale down, so I stop the. Okay, so later you should see it scaling down. Okay, so back here, right? So if I want to chain like multiple models together, so I can do like, for example, I pass it through a detector. Then this return is a reference to the result. So this result is actually stored in the ray object store in the shared memory. So this one is just a reference. It's like a pointer,
Uh-huh.
which I can pass to the next thing, like a tracker.
Okay.
So it doesn't pass the whole result, long big thing inside. But so this tracker, inside your tracker code, it will directly call this object, directly get this object from your shared memory. So if it's like, for example, a NumPy array, right? It it will do a 0 copy, so it's very fast.
I see.
Uh,
So that means the pipeline, right? You use this Python code to like determine the pipeline lah. Right? You just purely use a Pythonic way, and there's no Ray framework to like draw the pipeline lah.
this, I guess you can call this a ray framework,
Yeah.
kind of. Yeah.
If you want to do say branching, right, you just use the if else, right?
Yeah.
Right. And then after that, when you like say you want to combine results from the different nodes, you just wait until the how to say the variable is initiated and then it returns to the later calling function.
Yeah. It's purely in Python.
I see. Okay.
Mm. Yeah. So this initial message that I received, right? Because initially I didn't do this ray.put. So ray.put is to put this thing inside the shared memory. But initially I didn't put it. So when I pass this directly into my function, when I run it, they say it's an error. Like I pass too big message. I should consider doing this ray.put thing. Yeah. So
Two
now,
bit message, okay.
yeah. So now I'm explicitly putting this message inside the shared memory. So let's say my detector, tracker, UID all need this initial frame, right?
Uh-huh.
It doesn't like copy the whole message to each of these workers, ray workers. So all these references is all using zero copy read from the shared memory. Yeah. So it doesn't create like more stuff. Okay, so it should.
You ever had a chance to like measure the latency between the different?
Haven't yet. Haven't yet.
Okay. So that means for this example, right, your if and the else if, right, two different kinds of pipeline.
Yeah.
Okay.
So you should see it scaling down. Yeah. See, you see after a while it scaled down because now there's no request going in. So you can actually specify like minimally you only want 0, so it will scale down to 0. But here I say 1, so it will always keep like minimum 1 worker up. Yeah, so that's why it only scale down to 1. So it also help you like scale up and down according to how many requests are passed into this deployment. So another thing is this code is non-blocking because my return is not a value. This one is a future, so it doesn't block the code. So if I do it in a pipeline, right, even before this code returns any value, so even like my detector haven't finished running, this future will be passed like my tracker. So this main code will run unless if I want to get the value, I need to call ray.get, which will block the main code until the result is returned. Yeah, so you can depending on your pipeline, you can choose which way to do it.
I see. So that means if like say my detection is slower than the tracker, and then you use method right for the IEID lah. So that means your if the detection is slower, the tracker is faster. So that means if you don't use the talking method, right, your tracker will double process the old frame because it's referring to the old detection frame, right? Correct.
If I don't use the talking method as now like that.
Correct. Now it's not the talking method, right?
Yeah. So it will still cause the tracker still need get use the result of the detections. But then because this one is a future, right? My this I will go inside my tracker instance, but then the method so if like for example I go inside my imagine this one is the tracker, like I go inside, then before I get so it will block inside the tracker function. It won't block outside your code. So inside my tracker I still need to wait for the detector first. Yeah. It won't block the main code.
I see.
Okay, so and then the thing that Ray promised, right, is also scale up your code to like, cause now I'm just running on like one laptop, but they say if you want to scale your code to like one cluster, your main code requires like minimal changes, like 99% you don't need to change. So like all this, how you start your, all this running function, right? All this initialization, and then your main server code, main server deployment code, and then your main code also, you don't need to change a lot of things. But the main difference is you need to do a cluster configuration file. It's like instead of Docker Compose, you do a cluster thing, or you want to integrate to Kubernetes. Yeah, so that's the main difference. So it's very easy to say just scale to a lot of.
There's some questions inside the chat.
Oh. They also give us container with gRPC. We can also run with gRPC, but now it's still experimental, so it's not very stable yet. See the container now, this container thing also still experimental. But then it can work with gRPC, so we can use, so instead of calling like a array thing.
Yeah, I think you mean the gRPC call here, right?
Yeah.
Then you like put like the array.put, and then you put the results of the gRPC inside array.put, and then you pass it on to the next component.
So I guess
I think because it's a Pythonic way, right? There's the flexibility to like really use the different kind of stuff.
You can always do a request to an outside thing.
Yeah. The model serving, right? Is there any model serving framework? That means is there like a Triton backend or what? Or is that just you use just normal Python code, import torch, and then load the model, that kind of thing?
So it can serve anything. It can serve PyTorch, can serve like TensorFlow, Triton, TensorRT, Python function, anything you want to serve.
So that means you use the Python API to like load the model, the TensorFlow API.
Yeah. So like inside here, like import TensorFlow, then whatever.
I see. So that means it's the code way. There's no like actually like Python backend. Okay.
Unless you do it yourself. To edit in yourself, I guess. How we handle different environment for different module. Yeah. So that one is here when you specify like which image you want to use. So this image is a Docker image that I pre-built, and I load it into the head container. Yeah.
So that means your head is based on a base image, and then on the base image, right, you import this array detector class on top of this base image to form the children worker, is it?
No, so my base image is this one, right? The important one is the Podman and the NVIDIA Docker. So if I want to load in an image, right, like so if I bash in, I can do a Podman images. So here I loaded 2 different images. So if I want to load in a new image, I can do a Podman load -i, then you put like your whatever tar file.
So your detector, can you go back to your Python code, the 2 detectors there, the pipeline?
This one?
This one. Okay, so you have the array detector handle and array detector handle 2, right? So these are 2 different so-called containers, right?
Yes.
Yeah. So you are able to specify what base image you want to use for these 2 separate containers, right? Because
yeah, correct.
And where is the place that you specify this?
Here. So this is for the first detector. Then I can have one for the second detector. I can use like a different image.
I see. Okay. Then where does so that means the array detector is your main class, right?
Yes.
What's your main what's your entry point?
Here?
Can you scroll up?
Oh, I call this here in this script. I call this here. Then I do a serve.run to start. Then put this handle into my main script.
Okay, this one have to take a look. Have to take a closer look later.
So the serve.run is the thing that start this like job.
Okay.
Mm.
So previously, when you demo the local Docker version, right? You say it's just a purely Python client side of thing only, correct?
Purely Python.
That means you only use the Python SDK to like generate the container and everything. Is it still the case?
Yes, everything in Python.
So there's no say server process that's serving the you know what then like that how your web UI all those your Grafana all those is it part of the array the
All those metrics is I built additional container like for Prometheus and Grafana. So Ray inside Ray, right, they have like they got tell you how to integrate with these two. So like you can specify the endpoints.
I see.
Yeah. They got like instruction on how to integrate the metrics, all these metrics things.
Okay.
Mm.
Is there are there any like visualization tools for the pipeline?
You can build it in yourself now. I mean, in your metrics, they got like all these how many tasks running and stuff. Then if you go to Grafana, there's a bit more graphs that you can
No,
play with.
asking about the pipeline. So like let's say today your pipeline is like one straight line. So is there any visualization for the pipeline?
Oh, don't have.
Inbuilt. That's for Ray inbuilt don't have lah. Okay.
Don't have. Because it can be anything that you.
Okay.
Yeah. It can be like if else, a lot of if else.
I think overall I'm quite interested in the performance because you say it's the based on the memory reference.
Yeah, it's all based on shared memory, mostly.
But you say you are going to try the Redis integration next, is it?
That one is not within Ray itself. That one is the before part.
The old example, the previous example lah.
The before getting the frame part. It's like the restreamer. It's not the Ray pipeline. But you can also integrate Redis with Ray if you want to.
Okay.
Like if you want to lah.
Okay.
Then I think Kasha we will want to integrate Ray to manage the resources as much as possible. Cannot, cause if you want to do it in Ray, you need to make it a Ray deployment. Yeah. Yeah, so I think Ray should. I mean, for me Ray quite easy because you just need to connect to the head and run the function. But this function can be any function. So in this case, it's a class. And then the batching is like a optimization kind of thing. I mean, you can also deploy a Python function by itself. So if you only want to deploy like this function, let's say this is a very simple function like 1 + 1. Yeah, you can also just deploy that. And then very easy to pipeline it into pipeline it together also, I think. Then also manages the scheduling for you. Like the auto scale and stuff. You mean like what kind of things you can monitor? Is it? Oh no no. No no. Yeah. Mm. How does Redis integrate with Ray? No, like if you want to use Redis, it's like an external storage kind of thing. I'm not sure what we will use it for, like, if you want to use. But they say you can do it. So
But when you use a Redis, like say you want to like persist some output of your model, output the prediction to the Redis store, right? So that this will be done as part of the pipeline inside your code, right? I mean, as part of
yeah.
the under that what REID that section, right?
Can also if you want to use Redis. Okay, but I guess one caveat with Ray, right, is that all these containers that we use, these images, and like your Ray head image also, and your main code, the environment, the Python and the Ray version needs to be the same throughout. So you cannot have like uh, one model using like Python 3.8, then another model using Python 3.9, or like
Okay.
because underlying it uses like Cloud Picker. So they said there might be issues, so
Using what?
they use Cloud Picker.
Sorry again?
Let me check Cloud Picker. Yeah, so if you use different Python versions, there might be issues with like the pickling. So they don't allow it.
Okay.
Yeah. But a workaround is you can deploy them on different clusters, but then it will scale separately within their own cluster.
So this is one very big Docker Compose file that handles all the different images that you need.
Correct.
What's is the Docker, this is just the main thing, right? So that means the detector 1 and detector 2 is not over here, right?
Yeah, it's not.
Okay.
I just need head, head, and driver to start my code.
Okay. So that means you need to set up this how do I put it? So previously when you say that the Ray, right, that you experimented on with the one, right, that one only use on Clear SDK, right? So actually you use this Docker Compose, right, to like set up the server environment, the Ray server environment, because you are deploying all these different containers, the Grafana and then the Ray head, all that, So that's the server side of things, And then
Yeah.
when you start your pipeline, right, inside the Ray pipeline, if I'm not wrong, right, you do the init, right? Yeah, so this is the part where you actually this is your client side where you actually connects to the server processors to like deploy your additional stuff.
Yeah.
Just that everything is done using the Python SDK.
Yeah. Yeah.
Okay, I think quite promising, Quite promising.
Yeah. So that's all I tried so far. Still trying to experiment with this part, see how well it does, how fast it can go.
Yeah, I really go break down the different between the different line of code, right? Go log the timing and then see how it performs. I'm especially interested to see between the detection ref, track ref, right? How long does it take?
I get it running first.
Okay.
Any more questions? Yeah, at first Ray use Redis, then they move away. But they say you can integrate it as an external thing.
Does the Redis is from where? I mean, what's the use of Redis for the pipeline? Is it? No problems. You just type lor. Is it for the Redis for the between the component communication? I see. Okay. But Redis won't beat this direct memory reference.
Because at first we were thinking like to use Redis for the restreamer part, right? So that all these like detector, tracker, and data can get the frame from Redis. But now if we got the shared memory, then we can just read directly from the shared memory.
Can you scroll up? I want to see where you import the array.
Where I import?
Where
Here,
you import array. So you
import the
just import
detector,
array.
the handle.
Okay, you import array here, right? I mean the fourth line lah. Okay, and then can you browse back to just now the if else there, the put there, and then you have this on the line 49. You have this receive message reference.
Mm.
Then you put the received message is the actual payload, right?
Yes.
That's the JSON. That's the JSON payload.
After I loaded it into a JSON, yeah.
This the load. That means load already is the actual data structure, right? The NumPy is it?
The JSON,
It's JSON.
yeah.
Oh, okay. It's JSON.
But I don't know whether if I like put it into NumPy, will it be faster lah? I need to test also. Because now I'm converting it to NumPy inside my function. Yeah, so I'm not sure it should be faster.
Yeah, but if we to honest but if we say the Kafka is only for the entry point where you put in the frame, right? So the actual okay.
Because we change a lot of times. We keep changing it.
A lot of what?
Our idea keep changing. So that
Okay.
one old already.
Yeah, because previously I know you were using a Kafka to transfer the payload.
Yeah, we wanted to use that way.
Yeah, and we're having troubles with that now lah. Okay, anyway, so I just want to ask, right, in your opinion, right, so you know got the Ray library, right? So I need to import Ray and then I like Ray dot put the received message, right? So I can get the memory reference.
Mm.
Yeah. So for this memory reference, right? Oh yeah, but this memory reference I cannot use between different Python scripts because the memory reference may not share across different Python instances. Okay.
No, it's put inside the Ray object store, so it's shared. So even if different worker, it can read from the same object store. Because it's the same work, same node.
I see.
Yeah.
Okay, so let's say if I don't use this Ray pipeline stuff, okay, I just want a say in-memory approach to sharing objects across different Python containers.
Okay.
I can I just import Ray, then I Ray dot put this receive message, and then wherever I want, right, I just grab from this remote
So
location.
you don't want to use Ray for your pipeline.
No, I just want to use the memory in-memory stuff, the memory reference stuff.
I guess. I guess. But then you need to do all the setup, all your head.
Yeah, true. Then defeat the purpose, right? Okay. Yeah.
Yeah.
If we say the shared object store is the what is the radar put lah, then they put everything into the shared object store. Yeah. Okay. Redis okay. 你 Redis 给你多少钱？ Okay, I think so far I have no other questions thus far lah. How about others?
Then if don't have, you want to share ML run?
Sure. So just brief. Okay, since Ernest and Yinghui, you guys were not here previous when I explained previously, right? I just like try to like start from scratch. Pay more attention to the basic points. So for this is ML Run. This is like the Kubernetes setup by itself on the laptop. Then they have these different integration with other tools such as Prometheus, Grafana, Kubeflow, Apache Spark, and then this Nucleo and some other stuff lah. So far I only use the Nucleo and the ML Run stuff. I've not seen how does the other tools integrate with ML Run. Then at least on this ML Run, right, there's two basic things that we need to know, which is the kind of components that we want to deploy. The first one, right, is called a job, which essentially is like a Python script inside a container. It just run from start to end, and then the container is completed. Just there's no longevity to it lah. Then the other kind, right, is called a serving function. A serving function, so it behaves like a microservices. It exposes a HTTP endpoint, and then you just make a HTTP request to it. It will just process and return a response if there's a response. Just think of it like a microservice.
So this second one, it won't die lah. Is it? It will just stay there.
Correct. So the serving one, right, will not die. Not say will not die lah. There's no end to it lah unless you go kill the microservice lah. It's a cloud native thing lah.
I think quite similar to Ray also, because if Ray you serve a Python function, right, after it finish it will die. But then if you serve a class, so like for example the example just now, it won't die also lah in that sense.
Okay, this may be a bit of difference okay, because for ML Run, right, you can serve both function or classes in either way. Yeah, which I'll explain later. So that means even for the job, right, or for the serving kind, right, you can serve both. You can serve either a function or you can serve a class, because then you can specify what you want to actually serve lah. I will like share later. Is the code big enough for everyone? Is it
Can.
okay? So I'll start off with the pipeline first lah. So the pipeline, right, essentially is the continuous continuous serving functions, a series of continuous service function. So to like demo, right, I just run some things first. Yeah. So this ML Run, right, you actually got this feature that you can actually use this graph to plot out. So what I wanted to explain, right, so this entry point detection and tracking, right, they're actually deployed as three different microservices. Yeah. So the method of communication between them, right, the transfer of the payload, right, between them will be through Kafka topic. This one will go later. For a start, right, I'll just explain through my code and then like see how it goes. Okay. So basically, this the Kafka endpoint, and then this cell I will like ClearML. I'll need to like initiate a project instance. So a project instance, right, will store all of the functions that you deploy, all the functions that you run, right, all the logs, right, you will be able to view inside this. Okay, so over here, right, I will write three different files called start, and then this ZZ Ultralytics YOLO V8 and the DeepSock real time. So over here, right, this is only a function, and then over here this is a class definition. So for this ML run, right, if you are using a class definition, right, the default implementation, right, is you have an init method where you can specify additional arguments, and then you do your one-time loading over here, which is, I believe, is similar to the array. So you have the part for the one-time initialization, and then the part for the repeated running. Yeah, so by default, right, the do method, right, will be the one that gets repeated running lah. So it's the same for this DeepSock real time. So the pipeline, right, is essentially the endpoint does nothing. The endpoint, the entry point is just print out, just get the value and then just return the value. So just to visualize, so basically, right, the pipeline, right, it will be the entry point to the detection and then to the tracker. For ML run, right, how you break down these different codes, right, as per the array, right, is like this. So for every function, right, is a container. So you can actually lump one or more classes into a single container depending on how you want. So over here, right, this code to function, right, will actually create my pipeline function inside the ML run, and then it will read from this start.py, which is the first function over here, which is, and I specify is a serving class, and this is the base image in which that method will be built on top of, because every method will have their own, I mean every function will have their own base image, their own container. Yeah. So now, right, now that I have a main function, a main root, say like a main root entry point, right? So I can form a graph, which is the DAG. I can like do branching or what, but that one haven't got into it lah. So I'll just the terminology is they use a flow, and then to form the different pipeline, right, I'll just use a graph dot tool, and then as you can see with this, right, you can just form the pipeline directly. For this one, right, it just specify that it's in between is the Kafka topic as the mode of payload transfer. Yeah. So over here, right, so basically, this is the name for the detection, and then over here, right, I just specify this is the class that I want to read from, to run the function from, in which case I will refer to here. So this function will actually run this class. So when this container gets created, it will initialize, and then when this container endpoint is called, it will execute this do function. Yeah. So
Other than Kafka, still got what other different ways to pass the stuff between?
I believe the main one is this they call it V3IO. This thing, the V3IO service. I believe although they say it's like a persistent storage, right? Like similar to like S3, right? But I also read got some memory stuff, but I don't have the chance to like experiment with it. This is for the paying version. Yeah, and then after I specify this, right, I can just plot the thing out lah. So of course, because every function, right, is in a separate file, right? So and every function is a separate container because I define it this way, right? So I need to. This is just the syntax to like actually bring everything to Fruitian. Yeah. So just demo. It will take some time. Oh, okay. So for this function, right, you can actually say on the ML run base image, right, you can actually specify like say requirements is equal to let's say OpenCV Python, and then when you like deploy it, right, it will actually like build the container and then deploy it for you, and then it will take into account all these requirements and the additional functions that you want to include inside the container that this builds, the ML run builds. But for me, right, when I try building it this way, right, the container always give me an out of memory error lah. So what I did, right, I went to create my own Docker files and then upload into a into my Docker hub, and then I will call it from there. So over here, right, just to like say, show an example of a yeah, so basically, right, like for the deep stock real time, right, all I think is all these packages, and then I'll just do the pip install. Like then for OpenCV, I also just pip install these packages inside the requirements. So essentially, right, I build this image, and then I upload it to Docker Hub, and then over here, right, when the so I manually build the images already, right? I upload it to Docker Hub already, right? And then when ML Run wants to deploy the function, it will build a container. It will build the different containers based on these different images. So it treats these images as the base image lah. Okay, so I will like spend oh yeah, also there's a ML Run UI, and then this is the clear ML where you actually manage everything. You can also manage things from the UI itself lah. Okay, so just begin by running some. Okay, so I'm short of deploying. Yeah, so actually just create an empty project so far, and then I will go to deploy the function now. So you actually I deploy this root function, right? You actually deploy all the root and the sub child functions that I have declared. Yeah, so this will take some time, but so if we can see over here, right, this canonical job, right, just spawned. So if we go take a look at this, right, we can actually see that it's building the let me see which one is it. This one is my okay. So this is building. This it spawns a container to build the image for the ZZ Ultralytics, which is the second part, which is essentially this one. It will build this. So the sequence it goes is it will spin a container to build this function, and then when it's finished building, it will deploy the container, and then next it will spin another container to build this function, and then when it's finished building, it will deploy this function, and then finally to connect everything together, it will spin another container to build this function and then deploy it. Yeah. So the second one is the Ultralytics one. The third one is the deep salt one. So we can actually give it some time out, then it will just build.
Is this like a container in container thing also? So like the pipeline container, right? The main container. Is it like the mini containers inside that big
I would
container?
say it's not. So basically, I would say it's not. So this is the Kubernetes cluster. This is a Minikube cluster lah. So everything is within is as a separate container. the context, because if you see over here, right, this the over here is I'm listing down all the ports. So these are separate ports to do the different kind of things that I want.
Is there like a faster way to, I don't know, spin up the container? Can you like preload it in or something?
I believe that's the way, yes.
Okay. So if you save the image locally, then you don't need to pull from Docker Hub lah.
Okay, so for this one, right, I configured the installation, right, to use Docker Hub as the repo. So in fact, right, I can, because I understand, like for the ClareMail, right, we have our own local repo, right, in the AIP or the AIP. Then we can configure the repo to point there. So essentially, what it does, right, is that you also have the virtual control for everything. Let me find first. So by deploying this way, right, okay, so these three, right, are my base image, which I built manually, and then I call inside the code, right, I call it to build upon this base image. And then, let's see, okay, so it finished, so for just now, this thing, right, it finished building already. So after it finished building, right, it'll push the image to the repo. So in this way, right, there's like, say, the version control of the images for rollback and stuff also lah. So I think just now, I think will be this one now. So the late, yeah, so you just push a minute ago. Yeah, so after it finish building already, right, is after it's completed, right, it will spin out another container, right, to actually serve the function. And then next one, right, it will deploy this is the ZZ deep sort. So this is running the container to build the image for the deep sort one. So it's actually the same thing. So it's also doing the same thing. It's bundling the, how to say, it's bundling the Python class. This Python is bundling this Python class into this base image and then deploying it. Okay, so just now you shared about the replica, about the Kubernetes replica, the scale up, scale down, right? So for ML run, right, we also can do it this way. So it's like we can also specify as part using this Python SDK. It's like say spec.replica, if I'm not wrong. Let me find the thing. Sure. Yeah, so we also can like specify the different kind of things, such as the number of replica, the CPU and GPU with requests, and then the limits. So that means request is like how much you request, and then limits is how much you can go until lah. So this is like managed at the Kubernetes layer. Yeah, so it's similar to Ray. You also can specify this as part of the SDK.
Can you deploy multiple pipelines on the same file?
Multiple pipelines on the same file.
Like so if I put it into a Python script, right, your whole like notebook will be in like I
Yes.
guess.
Yes. Okay, so it's a bit complicated here. I believe the previous time when I explained to the rest, right, they also like a bit blur also. Okay. Also spend a lot of time to understand this. Okay, so this one, right, is the function name that's used in ML Run. Okay, my pipeline function ZZ deep stop real time function. So this and this, right, are the one used inside ML Run. So it's like the ML Run, what the function name for inside ML Run. And then if I want to use a class, right, I have to use the class name over here. Or if I want to use the method, right, I have to specify it as the handler, which is the start function over here. This one. Yeah, so if I use the class name, right, it will auto call the init during start and then do during the repeated calls. Okay, so the thing confusing about this, right, is I have three functions over here. So this one function, right, is my main one. So it's a serving function. And then the file name, right, is based on start.py, which is essentially this one. Okay, and then start function is inside start.py, right? So over here, I declare this function, and then when I do the graph, right, I specify the handler to call this function. So this start function is actually run from start.py. So this question is you asked me, right? Okay, so my class name, right, is the Ultralytics YOLO V8, but then I have no reference to this YOLO V8.py. So this is where it comes in. So this child function, right? So the root function add a child function, and then I call this ML run name. I specify this ML run name, and then it actually looks from this YOLO V8.py. So that wherever I say I call this function, it will link to this ML run function and then read the class YOLO V8 class from this YOLO V8.py. And then it will build using this base image. Likewise, for the ZZ stop real time. So this is the where it's a bit like not intuitive at all. Yeah. So answering your question, right? So if like I combine all my classes and functions inside one file, right, I can do it. So I just specify the file over here, right? And then but then all of the child function, right? No, child function. And I have not tried this, but I suppose I can just specify the same Python file, but I call the different class name. Yeah, or I can just use back the same function. That means I don't do this, right? And then I can just like say, if I want to have two start function in successive, right? I believe I can probably just do something like this, and then it will just do it automatically.
So you are not defining like a separate main function,
Sorry?
like your fn. So there will only be one fn, is it?
The fn, right, is your main entry point. It's over here.
So if like you want to serve two different pipelines, will you have like fn1, fn2, like two different graphs?
Okay, I will answer this question later. Okay, so okay, it finished deploying the function already lah. Okay, so if we look at all the ports, right? So essentially, I have three serving functions, correct? So over here, right, it has 3 jobs to build and then 3 jobs to serve. So if we go inside this is the main one, and then this is the Ultralytics one, and then this is the deep salt one. So let's go into the main one and have a look. Yeah, so this processor has started and then it's listening to the endpoint. So one way, right, I can do it, right, is I'll just let me change. This is 3 p.m. example. I'll just invoke this endpoint. Because this function already got the endpoint already, I'll just invoke it for example. Yeah. So if I were to go to the Kafka consumer, right? Yeah, so you can actually see the last example, right, is this a 3P example, and then over here. Okay, so basically, what it has actually done, right, is that I pass this JSON, into here, into the start function as adds. I do nothing, I just print a message. This will appear inside the container logs. There, this is the one for the start function. So I just print this log, this the container logs. And then after that, right, when return adds, right, it will actually go into a Kafka topic called topic 11. And then after 11, right, it will then go directly into here. Then because there's no frame, right, so I'll just merely append this detect done equal to true. Then likewise, after it returns x, the value will go into topic 22, and then it will go into deep sort real time this method. So because this is not executed, so it just go add another thread done equal to true into the Kafka topic, and then the end, right, will be this topic 33, which is this. So you see this. So can just do another quick run.
So the info is to run it lah.
Correct. So it's like it's this invoke, right, because the function already got the endpoint already, right? So this is the endpoint. The nucleo zzz my pipeline function dot, this is the FQDN of the endpoint. Yeah, so later I'll show an example of calling it for another different script. So now, right, I'll just like say this is the data, and then this is the 3 p.m. example plus 1. Okay, so I'll just shift, and then it will just travel through the pipeline, and then this is the end of the pipeline, that topic. Yeah, so it may look very fast, but it's just like so small only the data. Okay, so this is just a purely the pipeline, which is the, how to say, the serving portion only. So now you will ask, right, just now you were asking, right, sorry, what were you asking? Yeah, the frame thing, right? Okay, I think I'll answer your question now. so it has a endpoint, so this endpoint, you have to push the frame into this endpoint so that it will, like, say, process across this this pipeline, correct? So over here, right, this is a job. So let me expand this. Okay, so unfortunately there's some bad news. Okay, so basically, right, I follow a similar method. I import ML run, and then I set it to a project instance also. So over here, right, this is the endpoint. This is the endpoint of the pipeline, and then I have a video inside my container. I'll just like want to read the frame, and then I think this part you guys will be able to understand. So over here, right, it will just read the frame and then try to post it, use the Python request packages to post it into the endpoint. So this is the endpoint, and then just post it as a JSON. Okay, so now what I'm having trouble with, right, like I told you this morning, right, is if I put in frame data, if I put in the frame data, then it doesn't get pushed into the, so get pushed into this Kafka, and then everything just stop here. This just don't want to eat the data. But if I just push anything without the frame data, then it works all the way to the end of the pipeline. That one still troubleshooting. So even like I serialize the frame into a string, right, using your method, right, I still cannot put inside. So that's why I don't know. I'm not sure whether it's the size too big or some other things. So like to demo, right, Okay, so this is my extract file job lah. Okay, so this kind is a job. Why I say it's a job and it's not a serving function, because I just have a file. I just have to like process all the frames of this video file and then finish already ma. There's no like say longevity to this job. It will end sometime one. It's the same like RTSP stream. Although a RTSP stream is like probably will go on for forever, right? But there's logically there's an endpoint to the RTSP stream. So it should be implemented as a job where there's an end. Yeah. So that means similarly, your video path may be a RTSP stream lah, and then you'll just read and then you do until everything finish. Okay. So keeping in line with what I explained just now for the pipeline, so I have a project, I set the function. So this is extract frames drop.py to read from this cell file. And then this is the function name inside MLRun, which I will show you later. And for the kind, instead of serving, it will be a job. And then this is my base image. Because to run this job, right, to run this Python script, I will need the OpenCV2 packages and the other dependencies. For handler, it's not a class. It's this for here I specify a handler because this is a method and it's not a class. So this is a handler, and then I extract the method name, which is extract over here. And then over here, I'll just run function and then call this the ML run function name and call it to auto build, and then it will just do it. Okay, so let me just.
So the only way to call to like start it is to do a HTTP request. Is it?
Yes. Yes.
Then just now you say so this job will die when the stream die, right?
This job will what?
Like die when the stream like breaks.
This job will finish, not die. This job will be completed when the while loop you read finish the video, everything finished already the script end already ma.
So I need to take care of like, let's say it's a RTSP stream, then it suddenly like somehow like connection fail, then it break, then it start again. So I need to take care of that lah. I was like,
Correct.
okay.
Theoretically, right, you could have like a monitoring job. You can have a monitoring job to like go respond the RTS to respond this job again if it fails. So in a way, everything is very modular. Everything is modular. Yeah. So just show you so this MRR function now, right? This is only the serving. So now, right, I deploy it. So let's look at the end of the pipeline. I'm not sure whether this works. I hope it works. So I just run the function. Yeah. So if we observe the end of the pipeline, right, it's like ongoing. It's like ingesting the frame, and then this data is flowing through from the start of the pipeline, which I showed you just now, all the way to the end. Over here, I fill in the frame number plus I fill in the frame number. So over here, right, on the ML run, right, you will see that this extract frame, right, this is a kind of a job. And then you can actually like say, okay, that's yeah. And then if you look at the containers, right, you can actually see that this is the pod that's running. So after we reach about 3007, right, this pod will get is completed.
Just now in the first example, you run it with fn.invoke.
Correct. So
can you do that in like a loop? So instead of request.post, you do like fn.invoke, invoke.
Can. Then the context, right? I have to put the context inside this notebook instance or the Python script instance, because this function instance is over here, It's over here. It's over here. So what I'm trying to say, right, is if you are following this is follow the microservices way of doing stuff lah. So that means you have a pipeline, right? You expose the endpoint as like a microservice like that, and then the data flows through the different containers.
But if you do an invoke, is it through HTTP also?
Correct.
It's still HTTP.
This is still HTTP.
Oh, okay.
Yeah, there's
So
no.
it's the same lah.
Huh?
So it's the same lah. Doesn't matter. It's just a different way of calling it.
Correct. Yes.
Okay.
So that means the start, right? You can treat the start, right, as the job which I tell you about just now, and then over here, right, this is the HTTP endpoint, and then over here, right, that's actually direct is the PubSub already. Over at the Kafka side, right, it's all PubSub. It's handled automatically through this thing. Yeah. So one additional thing to share, right, is this may have a solution for the tracker model for the handling the state lah. Okay, so ML Run, right, they got this integration for this pipeline thing, right? They got this integration with the story engine. They call it a story. They call it story ML Run. Okay, built-in steps. Okay, so let's go here. So over here, right, you have these transformations or let's say all this kind of thing lah. Okay, so this is extend lah. Okay, so basically what this does, right, is let me search for a better example. Yeah, okay. So if you actually put this tab over here, right, say over okay as the first as the first one now, okay. Take it like this, okay. So that means let's say my original payload, if I was using a job, right, my original payload is just this JSON payload, just a frame number with the count. So that means whenever it comes at the start, right, it will become it will extend this incoming incoming data, right, with this with to manipulate the thing to extend this data, right, with something from this function. So let's say this function, right, merely returns this tag, right. So by the time this line or rather this component gets executed, right, over here at this entry point, right, the data is already like this already. So that means this is the way that the story engine, right, can manipulate the data. So of course they got some other kinds of transformation, such as batching, where you can actually like wait for 3 seconds, no, wait for a certain number of events before passing it on to down to the pipeline. Yeah. So in regards to that, right, because given my understanding of the tracker model, right, so like the tracker model probably like say let me take a look at the code. The tracker model have the budget of 10 frames, right? I believe this is the 10 frames. So that means there's a sliding window. believe it might be this. So that means it will pass in the window size 10 window into the next as part of the into the next component in the pipeline. So that means if the tracker actually just requires the bounding boxes from the previous 10 frames, right? We can actually like manipulate the data for the detection and the tracker, right, such that they accommodate this sliding window. And in this case, right, although there may be more data, I mean there may be 10 instances of the bounding boxes from 10 frames to be passed across, right? But essentially, the tracker, right, is stateless, will be stateless, can be made stateless. That's what I want. That's what my intuition is lah. So that means like say this NM budget, right, equal to 0 or what, something like that. And then over here, right, you actually update the frame from 10 frames or something like that. That's my intuition.
So you will need to save like whatever you need inside like
Sorry?
something. So whatever the tracker requires, you need to save it somewhere. Is it?
No. So that means if like let's say what is this? If this is sample window, right? So over here, right? So like over here, right? If I say dot to say story dot sample window, right? And then that means it will at this step, right? It will wait until it has 10 frames before it pass on to the detector over here. So that means, oh no, sorry, it should be after detector, right? After detector, right?
So does it work like for example, I have a continuous stream, right? So it passes in like say 1 to 10. Then the next step, is it 11 to 20 or is it like 2 to 12?
1 to 10. Okay, based on my understanding and intuition, I've not tried this yet. Okay, according to the documentation I read, it should be 1 to 10, 2 to 11, 3 to 12, 4 to 13, that kind of stuff. Successive windows.
Means if my tracker requires a lot of different things,
So
like
I'm just saying that there's a possibility to it. That if this works this way, then hopefully it can.
but is it more efficient compared to just save the state in the tracker?
No, this ML run, sorry, I answer another question first. No, the ML run story is not similar to the Ray object store. It's just the story, right? Is like a pipeline enhance library. It's like a library, right, to enhance your pipeline experience. So you don't have to like code out the things that you normally do using these functions. Of course, you can do it lah, but they with story, right, they can actually have a mechanism to like help you do it lah for some of the stuff. That's my understanding. Like say this extend, right? So like just now I give you the example of this extend, right? So instead of extend, if so let's say instead of this, right, instead of like x dot on, like instead of this, right, I want to like say additional parameter is equal to say time dot time. I can just put as part of this pipeline story dot extend and then a function time equal to time dot time, like that, something like that. This is like I would say like a convenience function. Yeah. Okay, then Ernest was asking about the multiple cameras, right? Then we have to use sliding window and use other story modes. Okay, this is actually a very good question. For the sliding window, right, I did not consider this aspect. Yeah, I don't believe this sliding window will be able to work for these multiple cameras. But for this pipeline, right, because it's like a microservices, right? So I believe at the start, right, over at the drop, right? So you will need to tag your video stream with some ID, which I believe you have done inside your yeah, you will need to tag it with some ID such as the URL, right? And then you have to put here, so that for successive components in the pipeline, which in order to separate the different camera stream, right, you can control the flow depending on the ID of the camera. Yeah, because there's the nature of the microservices, they are all stateless lah. But in this way, that's actually a state lah. That's actually a state, yeah. Because you have the tracker instance and the model instance over here. Yeah. Wait, what were you asking just now?
Is it more efficient compared to I just store the state in the tracker class?
In the what class?
Like I just do it like your way now. Like I don't do it the sliding window way. Is the sliding window way better, like more efficient, or?
I'm just for the sliding window, right? I'm just saying, according to my understanding, right, it might be the way that you can consolidate a state before passing it to the next component in pipeline.
But I can just store the state in the class like if I want to.
Of course, yes. You can. If I believe, if you want, right, you can make this tracker a stateful tracker if you want. Yeah, because the tracker is stateful already, ma. Yeah. So while this is like a microservice architecture, right? So it's like halfway not a microservice architecture already. So it still exposes an endpoint that you call, but whatever changes you make over here with the tracker, right, is stateful because the tracker over here is stateful. Yeah. They still have an endpoint over here. Oh yeah, so let me share with this. So we have the ML run. So for the serving, right, for the job, right, this is the job that you run, and then you can actually review like it's I think it's quite similar to like ClearML. For the pipeline, right, which is the kind of serving, right, you also can see this kind of stuff. Yeah, the serving is based on the integration, ML run integration with something called Nucleo. Let me see where's Nucleo dashboard. It has a Grafana and the Prometheus, but I haven't explore it to see what kind of information they pump over there yet. Yeah, so this is the Nucleo UI, and then this is my project. Then yeah, you can see that there's 3 microservices over here. So let's say I want to look at the main one, right? Then this is my function, and then you can see some other stuff, such as the function, right, which you can actually like configure the ML run, right, the API, the SDK, right, actually provide some method in which you can configure the function to trigger. So for over here, right, it's a default HTTP trigger. So of course, right, like just like I say, right, you can like trigger using different kind of stuff also. Yeah, this the default one, right, the inside the example they show is Kafka. I think this is the original one that they did lah. And then for the rest, right, I have not tried it yet. Yeah, so these are the different kind of triggers that you can use to trigger the different microservices. And this is the way, if you select Kafka, right, so this is the way how the subsequent this detection and this tracking are triggered. So if we look over here, right, this is the Ultralytics one. This is the second one in the pipeline. So if we go over here, right, you can actually see that there's a Kafka trigger. Yeah, based on topic 11. This one, not sure how it goes. Yeah, so yeah, lor, so this is just the nuclear integration. And then for the Python, right, just now I mentioned, if I never remember wrongly, you said that your Python version needs to be the same, right? For Ray?
Yeah,
Yeah,
Python and Ray version.
sorry?
Python and Ray version.
Okay. Yeah, so I don't I have not noticed the different versions. But because they're all based on the same they can be based on different base images, right? As in over here, they can be based on the different base images, right? But I built with the same ML run images. Yeah. For this, the prerequisite, right, is that you just need to maintain the client version with the server version, which is 1.2.1 now. Lah. Yeah, that's all.
The ML run version.
Correct. So you know the this is the server environment, or these are all the ports, correct? So this is the server environment, and then like say the Jupyter, the ML Run API, and then the ML Run UI, right? All these are the server processes that are serving all this stuff in conjunction with all the other ports. So over here, right? So wherever you spawn a container, right? So like let's say just now the extract frame drop, right? So when you spawn this, right, it will actually run this method. Yeah, and then this method, right, requires a CV2 dependency, which is inside the OpenCV base image. And then this OpenCV base image, right, is yeah. So the OpenCV base image, right, which I upload into my Docker Hub, right, is based on the ML Run 1.2.1, which contains a ML Run 1.2.1 client library. Yeah, so this client library, right, just needs to be the same as the server version. That's all.
Does the ML run image include like Python?
Yes,
So technically your Python version is also the same lah for now.
that is correct. But I have not seen any requirements that the Python versions needs to be the same.
You try.
Is it the Python version? Is it a very important thing? At least for your use cases.
For now still okay lah. But in the future I don't know.
I mean, do you foresee any issues if the Python version is different or not? That means your different the components that the different Python libraries that you need.
Might need to upgrade the old one lor. If like say some function some gets like deprecated or something.
Okay.
Like got legacy code.
How to get a Python run Python version, is it? Just let me see what is it. Not sure what this version is based on. What am I doing? Sorry, yeah. Okay, don't know how. Okay, anyway, so yeah, so I believe, yeah, so other than the trouble, right, of over here, right, where if I try to like say send the frame data inside, right, together with the frame number, even as a string, the it cannot reach the it can reach the endpoint. So it can actually go inside here and then print out the frame information, but it cannot go into a Kafka topic. Yeah, so that's why I'm troubleshooting now. So that's my update for today. Yeah, so you can compare this approach with the Ray and then like compare the differences. Because I now cannot transfer the frame over into.
You got try base 64?
Yeah, I, I,
Still also cannot.
I tried your code.
Also cannot.
I yeah, I tried this also cannot. I go Google do the what Python class all that also don't want to go into the Kafka topic. Yeah, basically 就是这样。Ernest say what if we continue model, then need to update all old model. Oh, got meh? Okay lor. Yeah, okay. So basically, for this model, right, for this V8, right, I basically just bundle it inside this Docker file. Yeah, I just bundle it together inside the image. Yeah, that's all. Then
I think I was talking about the Python version.
I'm just talking about the Python version. You say model uh oh, okay, Python version, okay. I can find out. I can find out if I can just like based on this old image, right? Yeah, yeah. Let me see something. Just let me check something. Uh, Installation setup. Three point nine. Yeah, it says over here 3.9 lah. But I believe if you need newer one, I can like how to say use a Python 3.10 base image and then I install ML run 1.2.1 to coincide with my server version and then I install the rest of the dependencies along with it. I believe that can be done also. I use the ML run 1.2.1 image to keep everything simple for now. Yeah. So does anyone have any other questions?
So for this one, if like you want to scale to like a cluster, multiple machine, is it very difficult?
It's handled by the Kubernetes. So I believe it will be like similar to what Ray does. Just now just now I show you this the job resource, right? So when you deploy the function, right? When you deploy a function, you just specify this. So essentially, it's like what you do, right? In the examples that I've seen, right? So before you deploy the function, right? Oh no, stop it. Yeah. So it's like you do something like this. And then like if you want to use the different GPUs, function dot spec, yeah, something with, it would be something, yeah, so it'd be something like this. I say CPU equal to 2, then mem is equal to, there's a mem, right? Yeah, mem is equal to like 8, something like that. 8G, something like that. So you can actually set over here, and then you can, how do I put it? And then just deploy it. So if you deploy it, right? Okay, sorry, I left out one important thing. Oh yeah, one thing. In addition, I wanted to ask you, right? I also wanted to ask. I forget to ask just now. Will be the node affinity. For this one, right? Because you can actually set with this, right? You can actually set node affinity for the Kubernetes cluster.
Is it like what kind of GPU you want to use?
I know. That means Kubernetes cluster can span multiple servers, but
Uh-huh.
so if like you want to you want it to like deploy on server one where it got the best GPU, are you able to like,
Or can way you can specify, like for example, if you have like T4 and then you have some A100, you can say like I want to deploy this one on like A100. Then I want to deploy another one on like T4, something like that.
okay, so you can have the choice of the node lah.
Can.
Yeah,
The
okay,
type lah, the type.
yeah, then that would be similar. Okay, let me see. I believe there's a YAML. I can't confirm now, but I believe, right, once you put already, right, there's some YAML which you can just deploy. Yeah. Yeah, so this is the YAML file for the pipeline. I never tried this approach yet. I use the Python SDK. But essentially, I think if you follow this, right, it will be very similar to the Ray style also. Then last but not least, I forgot about this, which is it's not the feature store, it's the function hub. Yes, this one. So for the internet one, right, they got this thing called a function hub lah. So it's essentially a hub where you can share your functions. So let's say I have this function, right, and then I do the, okay, no, not this, okay, this one, right, this extract, right, I have this function, right, I can like sort of like upload it into this function hub, and then where other people can just use the same code that I want to use. So it's the AI App Store, but this is the AI App Store for the ML run functions. And then the way to use it, right? So instead of like set function, right? I think you do something like project.set function and then do something hub : // some ID or the function name, something like that one. And then you will just get the function and then you can just run it directly. Yeah, this is the function hub. Yeah, let me see. Yeah, over here. So basically, you just set the function and then you can just run it. Then you can just run it. Yeah, basically, there's this additional stuff for ML run. Yeah, okay, I think that should be all from me for today. I don't think I did anything else already. So, are there any feedbacks, any concerns?
So if I want to do like a if else pipeline, I do it in my main lah. Then I just like request dot post
You do it over here. You do it over here.
over here.
You do it over here. So, okay, so in addition, right, I can also show you this. So they have this thing called a router. And then they use Kafka. Yeah, what's the thing? Yeah, basically something like this. So you can in fact combine pipelines of pipelines to form everything together.
As in, so the rectangle is one pipeline. Then you add on.
Let me see. Router M1 at route 1. I believe so. I believe so. Route. Yeah, I believe so. So that means over here, right, if you router, you add another route, right, called M2, right, over here, right, then it will spawn out another line down over here. Router to both M1 and M2. There, because it comment away this one.
But the M2 extend from M1. But
No,
if let's say
router to M1 and router to M2.
Okay.
At route. So essentially, this is the same. This line is the same as this.
It's like a branch lah.
Yeah, the router will branch two ways.
Oh, okay.
Yeah. Then after that, right, you can use the normal .2 to continue our pipeline if there's additional components down the pipeline. Yeah. So what this differs from the array, right, is that you have also. I mean, this also has a Pythonic way, with the additional story library to form the thing. And then I think the good thing about this is that you can visualize the pipeline lor. Yeah.就是这样。Yeah, so that's now the V12, right? This one is V12 stream. I've not had the chance to use it yet. It looks like a 4x3 kind of stuff. Yeah, that time I tried to install, got some problems. Yeah, so I use back the default one will be the Kafka one lor. Yeah, so 就是这样咯。
So what? Like whatever you want to pass to a separate function, like for now it needs to be like it must be able to go through Kafka lah. So it must be.
Yeah,
Okay.
Encapsulate the thing inside the JSON and then put it into Kafka. So alternatively, right, Kashon previously mentioned, right, I can just use Kafka as the metadata 的那个 mechanism. So over at Kafka, right, I just pass the key of the, okay, so let's say probably Ernest will be very happy lah. So over here, right, at the do, right, I will like x is the key, x will be the key is equal to like say x. I just use Kafka to transfer the key, which is essentially very fast because a key is just a key. And then this is the Redis key. And then so over here, right, I declare Redis instance is equal to like Redis dot connect some IP and then some endpoint. Okay, so I will like say frame data is equal to self dot get key, something like that. And then I process frame here. Yeah. So nothing is stopping us from just passing the metadata through the Kafka, but using other means to like actually transfer the payload. Same as your reserve, ma. If you don't want to use your in memory, you don't want to use your memory stuff, you can use the original approach you use for the Kafka also, ma. Yeah. OK, right，这个你听得懂哦。Yeah. So 就是这样。Nothing is stopping us from doing this.
Oh yeah, another question. So like you say in like this class, for example, right, the default one is it will run the do function. Can I have like multiple do function? Like do different thing. But using the same model.
Using the same model. This one I'm not too sure, but if you are trying to put it here, right, I'm not sure whether you can do like say specify the class name and then you specify the handler, which is essentially the method name.
Yeah, can do something like that.
I need to try this. Need to try. Alternatively, are you able to like branch inside here instead?
Oh.
You also
Okay. I get what you mean.
yeah branch inside here. Yeah.
Okay, then another question is there like a auto batching function?
So yeah,
So like cause now you send like one by one, right? So your function, your
I think
thing run one by one.
You asked me this before, but can I hold off the answer first?
Okay.
So I just have a 想法 lah, okay? So like let's say if you have say I'm not sure, let's say you have 2 video stream, right? And then this is just one instance, right? One microservice, right? I'm not sure whether you can have like say self dot trackers equal to like that. And then inside your stream, right, you got let's say your ads, right? You for every video you have the cam URL, right? So you can like tag the cam URL as inside here.
Maybe I ask another way, like not tracker, let's say like detector.
Huh?
Let's say like not tracker, let's say we look at the detector. So like now you're passing like one frame by one frame to do the detection. But can I do like auto batching? Say like if I got too many requests, can I do like 4 frames at the same time?
Answer your question first. I believe previously you asked me about this. I think it's this one. Batch. not sure whether it's this or not, but previously I told you the ML run, right? They got this battery, right? So they will either wait. I can't find it now. Wait, let me see. This one. It batches the event, right? So you put this, right? You put this story.transformation.batch, right, as part of the pipeline over here. Then essentially 就是这个啦. Essentially it's like this, right? And then you have some parameters at the back. This one never tried before. But my understanding, right, is you can do this. So you can batch until you have some events or you have some elapsed time. Let's see whether it's the case.
So my batch is for the whole pipeline, not for each and every.
Correct. Yes.
So if I got two different pipeline, but then they both use like the same detector. So it's a. Will it spin up two instances of the detector?
Probably not. But over here, there's the key. This key by which events are grouped. So probably you can group the events by the key. So you set this key as part of the incoming payload, and then you probably can use this to segregate the two different camera URLs.
No, but let's say I don't care about the segregation.
Okay, so I wanted to explain this just now, right? So I was thinking like for this one microservices, right? So instead of this self-tracker .deep sort, right? So let's say if X, so cam URL not in self.trackers. So I have these trackers with a dictionary okay. And then this empty at the start and then like then I'll do set 那个 self.trackers X. I'm not sure whether you get what I mean or not. Something like this. And then after that, right, I don't Python got switch or not.
就是 like instantiate a lot of tracker lah.
对, so if the key is not.
It's like what we are. Okay, can.
Yeah, I mean, I just thought of this. I'm not sure whether it's a correct way to do but like that, if your how to say if like say one of your video stream die your tracker forever here, you need to have some kind of a cleanup law.
I think it's the easy way to implement law.
Correct, like maybe this tracker never used for half hour and then you will just remove the tracker from memory and free up the memory. That those kind of housekeeping job Yeah, I mean not say it cannot be done it can be done this way also Yeah, so I mean it just came to my mind you can do it this way also
But this one, okay, never mind.
I also but if 我是在想这个跑这么快if the frame keep coming in don't know whether there's any like say race condition before this tracker is created. Don't know have to try really. Never tried this before.
But then 我要问的是if like I got this pipeline, right, like detection, tracking, detection and tracking. Then I got another pipeline like detection and VID. So like FN, then FN2, 对吧? Is it something like that?
I think
so it create a separate. Okay. So it will be FN just 一个 FN. Then I branch it to tracking or like router the router thing. Okay.
我想一下I have no answer for you now. There may be multiple ways to. There may be more than one way to do it, but I don't know what might be the better way. Because like I say, right, this is one single pipeline. Then this is essentially one graph, and then you can combine multiple pipelines together. So I was thinking, right, you can like have declare function 1 and function 2 for two different pipelines, and then you have like a router to route to both pipelines at the same time.
Yeah, okay. So let's say I do that way, then both pipelines got a detector, 对吗?
Uh-huh.
Then will the detector be the same instance?
Oh, that's a very good question. I don't know.
Okay. Okay.
Let me see. If that's the case, then maybe I'm not sure whether the SDK will take care of that or not. But if that's the case, right, you can probably just spawn the detector as its own component, as your own serving function. That means instead of the code to function, right, you instead of the long pipeline, right, you just have a detector. And then this detector will just spawn a how to say we'll just have a HTTP endpoint, right? And then we'll just return the result to the calling function.
So I don't put it in the pipeline.
Correct. You take care of the pipeline, and then you in your pipeline, right? You just make a call. You just make a call to it, and then the call will return you a response. And once you get the response, you just continue your pipeline. This is what I think can be done. But if what you are saying can be done using this, right, or some router, right, that one can explore. That one need to explore. I'm not saying it cannot be done. I never tried before.
Will you be trying?
I don't think I'll be trying in the near future.
Okay.
Yeah.
I think Ernest asking for Ray detection very fast, UID very slow. Yeah, no,
Asking you.
VID will have backlog because it's a totally separate instance. They don't wait for each other.
The re-ID is sequential one, right? You cannot jump out one, right?
Sequential, it
Need,
mm,
if it's not sequential, right, then you can set more replica.
yeah, cause in the middle I got tracking. Tracking is sequential. I need to think.
Yeah.
要想一下。
Yeah, so 这些要 engineer 出来咯，那个 solution. Yeah, so you can see from the state of things that I've shown you today, right? There's still a lot of things that haven't tried. But overall, right, I feel that the ML run, right, at least for ML run, right, it provides a lot of the functionalities, right, that we were previously looking at. Yeah, and these functionalities is what we wanted, and then we found it in ML run, and not ML run got these functionalities that we wanted. It's the other way around. Yeah, so so I think it's quite a viable product on top of the Ray.
Okay. But then, because ML run harder to get started, a bit like, hard to come up with the pipeline and all that stuff. Quite a bit complicated, I think, for the first time.
OK， 你要想因为我的想法是when it comes to deploying the production pipeline, right, you want something that's consistent. You have a framework, and then it will just get you right. You get what I'm trying to say? You define the pipeline, right, using a framework, right? If it fails, it will fail. You just have to get the pipeline correct already, and by following the framework, and then you can just deploy the thing very fast. Yeah, so you are not doing it like your own way lah. Like because like today you do your if else like in Ray pipeline, right? You use an if else, right? And then other people may use different things to do the branching. I'm not sure.
Actually, Ray can also do like what you are trying to do, like chain them together. But then think cause I didn't try that lah. Cause very,
Yeah.
I think it feels okay lah. It's the same. It works the same way. Just like it's more Pythonic lah. I feel.
I believe right, for the Ray one right, have to like how to say a possible way right is like have a wrapper over the different kind of things that you want to do right, so that this time when like say your teammates they want to like say form a production pipeline very quickly you can just call this wrapper to piece together and then you can just don't care about the underlying one right, and then just deploy the pipeline to test it and then productionize it. Yeah, that means the wrapper right is like a sort of like a framework for them to easily do their stuff You have to like consider this aspect to see whether you can operate in such a way or not.
Can you can also write the wrapper ma. Like you write another say.
Yeah, but everybody must use the same wrapper.
Yeah, can.
Yeah.
Like,
Otherwise, like today, you how to say production like today you just like deploy this already, but there's actually like say someone else maintaining this. Where this time they need to upgrade some things. If everybody is following the same framework, right, the upgrade can be will be much easier to do. But if everybody is like doing their own stuff, then wow, the SA confirm 背翻了。哇，这个 code 不同，那个 code 那个 format 又不同，then 要做一个 upgrade 可能就要花好几个月。But if everybody is following the same framework will be the risk is low and then it can be get done much faster So that's one of the reasons why when we are looking at the production pipeline, right, we want something like a framework to cover it also Yeah, that's the reason
I can think of a wrapper way for Ray also lah.
I mean, we don't have to do it now. I think the more important thing.
而且我想 it's in my mind now.
OK 我觉得现在重要的东西是like how to make the things easy for the developers to quickly come up with a pipeline and then just to deploy it and get it working, and then also enjoying the benefits of like the native scaling inside the Kubernetes cluster and such. Yeah. Think like how to say production, not development.
Okay.
Yeah, measure your performance, please. I'm very interested to know.
Okay，等我做那个 pipeline 出来先。
Yeah.
Okay, yeah, no more factor already. 我没有 factor 了。
Others okay 吗？Okay. Yeah, understand. And I took out a lot of it. Okay, anyone else have any questions? If not, then we can like call it afternoon. All right, then goodbye everyone. Bye bye.
Bye.